In this section, Module 4, let us have a discussion of modulation of uplink control channel, that is PUCCH. As already we are aware about that, only one control channel is available in the UCA. So let us see for what purpose we are going to use the modulation of this channel. So this modulation scheme is determined for the scheduler in the MAC layer when UCA is transmitted on the shared channel. So whenever we want to transmit the shared channel, we have to schedule, that is determine the scheduler in the MAC layer. Here we will discuss about the modulation scenarios. What is the scenario when UCA is not transmitted on the uplink control channel, that is no uplink resource is assigned to the user equipment, then what type of transmission or what type of modulation has to be taken place. So here the following tabular column will give the modulation scheme and number of bits per subframe. So here we can see what for format number 1, 1A, 1B, 2, 2A, 2B. Here what are the types of modulation scheme has been taken place in the absence and the presence of the bits. Such a way, let us go for the next. We will see each and every format, that is format 1, 1A and 1B. Here the first format 1, 1A and 1B. Here HARQ acknowledgement and scheduling request are transmitted without the channel quality indication bits. Whenever the acknowledgement and the scheduling request bit is transmitted in the same subframe, there will be possibility of two types of transmission, that is negative scheduling request transmission and positive scheduling request transmission. So if you discuss with at what time or what scenario we will call this as negative scheduling request transmission, that means the user equipment transmit the acknowledgement signal on its assigned acknowledgement control channel. That time we will call it as the negative scheduling request transmission. Whenever it is we will call it as positive scheduling request transmission, in the sense whenever the acknowledgement is transmitted on its assigned scheduling request control channel. So that time we will call it as a positive scheduling request transmission. Next we will see about the formats 2A and 2B. In the format 2A and 2B, this format types are used to whenever the m bits is greater than or equal to 20. So here whenever the m bits greater than or equal to 20, the first 20 block bits, that is first 20 bits are scrambled into B of 0, that is B of 0, B of 1 up to B of 19. And this scrambling will be taken care by a user specific sampling sequence. Then this scrambled bit will be get modulated by the quadrature phase shift keying scheme, and the result of this modulation scheme is the block of complex valued function. So this is, here we can see this d of 10 is the complex valued function, and the format 2A, 2B, and what are the block bit B of 22, B of 20, comma P of m bit minus 1 is shown here. So this diagram clearly shows that the complex valued symbols is multiplied with the length of 12 cyclic shifted version of that is we will call it a side of Chu sequence. This side of Chu sequence is nothing but a mathematical sequence. When we applied a signal with this sequence will give rise to a new signal with constant amplitude. So here first we will discuss about the multiple this tabular column shows that how the complex valued signal will be obtained by using the SAD-off sequence. Uplink control channel from multiple user equipment to be transmitted on the same resource block using a code division multiple access. Now we will see the resource mapping. So in the upper link control channel is time multiplexed with upper link shared channel from the same user equipment. Already we know that there is only one control channel and this can be shared to the shared channel also. Here this is why we want to do time multiplexed, in the sense in order to retain the single carrier property of SCFDMA. We already know about that SCFDMA, which is the modulation technique we have used in the uplink transmission. So in the TDD mode, the upper link control channel is not transmitted any of the UPPTS field. This UPPTS field, which is only for the transmission of uplink sounding reference signal. So next, here it's very clear that in the resource mapping graphical representation, and before the graphical representation we will see the formula, that is using a modulo 2 addition we have written as n PRB is equal to, this is the formula that we are taking it as a rule. According to this rule we have mapped here. This is the resource block mapping. Resource mapping has taken place. In this diagram it is very clear. You see two slots are there, that is one subframe, even slot as well, even numbered slot as well as the odd numbered slot. So even numbered slot and the odd numbered slot is put together is called as one subframe. So in this diagram it is clear that uplink control channel is transmitted at the bandwidth edge to provide the data transmission in the middle bandwidth. So frequency diversity happens during the frequency hopping between the different slots. So even the mapping is taking place in the subframe where frequency hopping is taken between the slots. So there is a possibility of frequency diversity. So here it is very clear that localized resource allocation is also allowed in the uplink, is also applicable for this bandwidth. Already I have discussed about uplink control channel is transmitted at the bandwidth edge, that is due to the localized resource allocation of the uplink. Here the frequency hopping also raises the frequency diversity.